All right, welcome in. Welcome all. As you're joining us for our webinar today on aligning STEM with Florida standards, please let us know who all is joining us today. Tell us in the chat, what's your role? What's your grade level of focus? What district are you joining us from? We'd love to know a little bit more about who all is going to be with us today. And as we're letting everybody sort of trickle in over the next couple of minutes, please tell us a little bit about you in the chat. We'd love to see. We'll give just a couple minutes for everyone to join to make sure that we're all on board before we start chatting about how we can integrate STEM into your schools and districts. If you're just joining us, please drop in the chat who you are, where you're joining from, your role, your grade level, your district. We really want to tailor this time to be the most useful for you and your focus, your students, your district. So the more that you can tell us about who all is joining, the more effective this next seminar can be. Great. Okay, wonderful. Seeing some CTE coordinators, principals. Great. Some administrators, some communities and schools. Wonderful to see organizations that work alongside our schools in the chat as well. Great. Some CTE directors, definitely. We're going to touch on a lot of our career and technical focus, especially as it relates to STEM, as that as part of the STEM umbrella and as they interact, we end up having a lot of conversation around CTE when it comes to STEM. Great. If you're just now coming in, please tell us in the chat who all is joining us today, your role, your grade level, your district, so that we can make sure our time together is the most useful. Great. Seeing some elementary as well as high school, middle representation as well. Wonderful. Well, as everybody is trickling in, I hope you can continue to tell us a little bit about who all is joining us today. As for our side of things, my name is Hope Thompson. I'm a senior manager of curriculum and instruction at NextWave STEM. Prior to my time with NextWave, I was an elementary science teacher in Baltimore and Chicago public schools. So I have not lost my teacher brain nor my teacher heart. And so I hold all of our partner schools and students close. And I'm really excited to share the resources that I know are most meaningful for teachers. I've also held roles in instruction and curriculum design for robotics from pre-K all the way up through 12, which I like to mention because, yes, even our pre-K students can be included in the conversation around STEM. Whenever we talk about STEM, computer science, CTE, I think it's helpful for us to remember that we're making a place for every student in that conversation and that there is a role of STEM in every student's life as well. So I just like to highlight that all of our students, no matter who you're joining us representing from a grade level, district perspective, there's something here for you and for your students. And I'm joined also by Tarita Aurora.
Hi everyone. I'm really excited to meet you all guys here. I'm working with Florida districts. We are working heavily with Miami-Dade, Broward, and Palm Beach. If you need any help from us, feel free to reach out towards the end. I'll drop in my calendar link as well in the chat for you to schedule a time if you have any questions. I'm happy to help you. Thank you.
Thank you, Tarita. And as we're getting started, like I said, I want to know more about who is joining us and what sort of STEM exposure and expertise we have with us today. So take a moment, if you can, to share a little bit about your current approach to STEM as a school or as a district, depending on who you're representing, maybe even your classroom, if we have some classroom teachers with us today. On this scale from 1 to 4, where do you see yourself? One being, I'm interested, or we as a district are interested in integrating STEM, but we don't yet have a STEM program. We're just beginning to introduce some STEM initiatives. Maybe level 2, having implemented some STEM, a standalone project, a STEM night, an after school club. We're starting to roll out STEM as a focus. Three, we have a STEM curriculum. We have resources that we rely on. Maybe we're still building buy-in. Maybe we're still building fidelity across the school or the district. It's been spearheaded by one individual teacher or one individual school, and we're trying to get everybody else caught up. Or we've got a great program, but it's all after school. We want to make sure we're bringing it to all students. And then four, maybe you have a year-round in-school STEM curriculum. You've got a program. Maybe you're happy with it, or maybe you're looking at alternatives, but you'd like to learn a little bit more about what is out there, what your options are, and what's available. So take a moment to assess where your school, your classroom, your district may be along this scale. Oh, great. I'm seeing a lot of threes and fours. Wonderful. Great. Between two and four, yeah, some variation there. Great. So we have some familiarity and some approach to STEM existing within our schools already. That's wonderful that that's something your schools and districts have already focused in on in a way that is targeted and effective. And we're a little bit further into the conversation than just thinking about STEM. If you are joining us and you're at one or two and feeling a little bit quieter in the chat, no worries. I want to make sure that there is something for everyone in our time together today. So no matter where you are, between one and four. Hopefully by the end of our time today, you'll feel like you're ready to move up a little bit further. If you're at three or four, you're already ahead of the curve. When we surveyed schools, 70% of the schools that we spoke to had no STEM curriculum that they could rely on within their school day. So if you're already ahead of that, wonderful. And if not, hopefully you'll feel some comfort with exploring those options by the time we're done today. I'm curious about your biggest barriers to STEM. So if you're at like a one or two, what's keeping you from really launching a program? But if you're at more of a three or four, which seems like most of our participants today are, what is keeping you from really optimizing your STEM? What do you feel like are the barriers to the most successful STEM implementation? What are the challenges that your program is currently facing? If you could just drop a couple ideas in the chat of what is keeping your programs from being the STEM programs of your dreams and your students' dreams, what kind of barriers have you encountered? Yes, having qualified instructors is a huge thing we hear about. Absolutely. Needing a lot of support, buy-in, absolutely. The time, when is all the STEM instruction happening when our school days are so busy? Finding the funding, finding the staffing. Yeah, these are a lot of the barriers that we hear all across that spectrum from one to four. At every level, we hear the same barriers come up. Time, staffing, funding, the curriculum and programming, what are the resources we're using, and that content knowledge as it relates to staffing, especially. How do we make sure that the educators have the background knowledge and the buy-in to provide high quality instruction on these highly specific emerging technologies? Absolutely. Well, all of these barriers are a lot of the reason, a big part of why NextWave STEM exists at all. We believe the world needs young innovators, so we offer hands-on courses in emerging technologies. We want to give students confidence. We want them to get opportunities to practice collaborating and creativity, learning to fail and taking academic risks in the classroom. And so to do that, we want to empower our teachers to prepare students for what we often consider careers of the future, the world of the future, but more and more is the world that's already here. Our students are already engaging with these technologies. The landscape is developing rapidly. Our students have already arrived in this world. How are we equipping them to be prepared to excel? And so all of what NextWave STEM develops, our curriculum, our programming is around this idea that we want emerging technologies in STEM to be more than just a 3D printer that we got. And the teacher who really knew how to use it has moved on and we're not sure what to do. We want to make sure that these are sustainable solutions that long-term educators can return to year after year without having to worry about the buy-in or the content knowledge that one educator or one initiative had, but is consistently replicable. So before we get into the nuts and bolts of the content, I want us to think critically about what we mean when we say STEM. When we are thinking about STEM programming, we know, of course, science, technology, engineering, and math, but that can be interpreted a lot of different ways. And we want to focus on three major pillars of STEM programming that is high quality. The first being the process, giving students an opportunity to engage in the science and engineering design process of asking questions and identifying problems, imagining solutions, planning them out, creating and testing them, and engaging in that iterative process over and over again to improve them. That process of design is not just found in engineering and science, but is something that crosses over when students are engaging in the writing process in ELA. They're engaging in a very similar process. These are skills that are not just within the silo of science and engineering. We know that there are skills that can lead to success in problem solving across a lot of different disciplines in a student's life, in and out of school. We also want to think about exposure to technologies, the emerging technologies that have been produced as a result of that process, the innovations that students may already have ideas about, especially when it comes to drones and AI and robotics. They may already engage with in some ways. These are the sort of things that were developed as a result of experts using that engineering and design process. And exposure to these technologies have their own value in building engagement and buy-in for students, giving them experience with using technologies that they may rely on later on in their careers. But it also helps them see what can happen when they engage in that process. And then that final pillar are those measurable computer science skills, giving students the time to practice decomposing problems, sequencing, giving them real practice and mastery of skills like coding through block coding or text-based coding, especially for our older students. And when we're thinking more in that CTE direction, giving them the skills that will be immediately useful outside of school. So some combination of all three of these aspects and categories of STEM combine to make a high quality STEM program. But how do we reach those STEM goals? How do we actually implement a program with all three pillars? We see schools and districts successfully do STEM in these two pathways. One being standalone STEM instruction, protected time in the school day for STEM, not as a part of science, but as its own block. An after school program that could be a robotics club or a computer science club, time where STEM is protected for its own sake and for the instruction of these three pillars. And on the other side, we see schools who may not, districts who may not have the time, the resources, the staffing, some of those barriers that we brought up at the beginning to protect a standalone STEM instructional period. And so then we look at integrating STEM into core subjects. How can we bring in the engineering and design process into your ELA classes? How can we make the writing process feel more like the engineering design process? How can we bring a technology into core subjects using AI to build a chatbot that behaves like a historical figure that they've learned about as a way of showing an assessment and an artifact of their learning? Or how can they bring in some of those computer science skills into math class, for example? Can they code a simulated drone to reach coordinates on a plane and show those coordinate skills maybe as a third, fourth graders starting to think on the plane for the first time? We have these two different options depending on what the goals and the constraints of your school or district may be. And we're going to dive into both of them, an example for each of what those STEM programs can look like. We're going to start with STEM standalone STEM instruction. And this is for schools that can say, we're going to dedicate this time, whether in school or after school, to the process, the product, and the skills of computer science and STEM. So I want to take some time to look at the Florida standards for STEM as it relates to computational thinking and computer science. Since we have some people in the chat today who are at 3 and 4, some CTE experts, some STEM coordinators, you may have familiarity with these standards pretty deeply, but especially for those who are joining us at maybe the 1 or 2. There are two major buckets that the standards for computer science fall into within Florida. On one side, there's the computational thinking, and these are universal from K through 12. They, for all students from K through 12, are broken into these 7 topics. Of course, having varying levels of complexity, but as the overarching thinking that we want our students to be practicing. Actively participating in effortful learning individually and collaboratively, demonstrating understanding by decomposing a problem into smaller pieces, completing tasks with digital fluency. This can refer to a lot of different skills and mastery of hardware and software. Expressing solutions as computational steps, thinking about sequencing in and out of a computer science context, creating an algorithm to achieve given goals, differentiating between usable data and miscellaneous information, and then solving real life problems in science and engineering using computational thinking. So those 7 ideas are going to extend across all of the standards from K through 12. But we do see standards broken down into more specific concepts for our K through 5, 6 through 8, and 9 through 12 students. All of our students from K through 12 have these 5 categories to begin. These are the 5 categories of focus for our K through 5 students. Communication and collaboration, thinking about using digital tools, researching and using the internet, problem solving and innovation. Personal health and safety, practicing safe digital use and understanding the consequences, the mental and physiological effects of device use, promoting safe device use for especially our youngest students. Computing components, understanding the parts of a computer, creating and using digital artifacts, and troubleshooting. Programming and software engineering, that's where we're going to really see broken down some of those computer science coding skills, decomposition and sequencing, data sorting, representation, using conditional logic and if-then thinking, and then technological impact, understanding the progress of technology and its impacts on human life, work, culture, and accurate use of sources across the digital space. Understanding copyright, citation, assessing whether something is accurate and a reliable source. So these 5 categories set the scene for our K through 5 students. And then our middle school students add on 2 more categories: emerging technologies, understanding things like artificial intelligence, AR, VR, robotics, and their impact, and then cybersecurity, which is going to include the physical security of devices, network security, and social engineering. And then our high schoolers also add on a category of financial use and cryptocurrency, understanding the landscape there as well. But all of our students are going to build on those same categories as they grow throughout their learning. So for a program that has a dedicated STEM standalone time, you can provide that time for practicing these standards and hitting these standards exactly. So depending on what kind of coursework you want to focus on, those different categories, you can use a variety of topics and pathways to reach those standards. You can see here on this chart of NextWave STEM's offerings, across that top row, you're going to see our 7 categories, what we call our pathways. And these are the topics: robotics, drones, AI literacy, 3D tech, innovation, sustainability, and game design. Different combinations of those topics can be combined and used to reach those standards and the goals in different ways. So a lot of those programming and software engineering, computing components, and even emerging technologies, those standards are going to come up in the robotics, drones, AI literacy, game design. They're going to give students a lot of opportunities for practicing using loops and conditionals and variables in their coding, understanding the impact of these technologies. Something like our 3D design, innovation, entrepreneurship, and sustainability is going to provide students with more opportunity in the technological impact, safe use. There's a cybersecurity aspect as well. So a different combination of these courses can help a single grade or a school or a district hit all of those computer science standards. We're going to look at just one for an example, and we're going to focus in on what that robotics pathway can look like for students in K through 12, what standards we're hitting, and how that those concepts can be explored from our youngest learners all the way up to our 12th graders. So for our K through 2 students, and I will include our pre-K students as well. I've seen it done with pre-K students, and they are oftentimes ready for some of these simpler conceptual ideas around robotics. Our K through 2 students really think about the concepts of computer science as they relate to telling stories. So the ideas of decomposition and sequencing before we introduce any coding can be used to help build students' ELA skills as well. But it's also a great place to start with just practicing those skills of when you brush your teeth or when you tell a story, how can you break that into smaller pieces? So the students use a Colby robot where they are coding right there. They're only thinking about hardware, not yet making that connection to the software because this particular robot is holding programs right as students are inputting them. So students are using Colby to navigate mazes, draw numbers, tell a story. They use Colby to hunt for treasure. And they get to understand those basic coding concepts. So for example, I've pulled a couple of the more detailed programming and software standards from first grade. Explain that a computer program can only follow a set of instructions. That's a big part of this course for our K through 2 students. We want them to understand that these robots are not thinking on their own. All they can do is what we tell them to do. And also create a pattern that can be repeated to complete a task. So in a lesson where students are exploring how to draw numbers by using Colby, they are discovering that different patterns can be repeated in order to draw a 2, for example, on a grid. These will later on in later grades be the kind of skills that students build into using loops and variables, making those patterns more simply represented in their code for a more efficient code. But with our youngest students, we really just are building the foundation of those concepts. Now, our 3rd through 5th graders are ready to have a little bit more complexity in coding. We're relying on a block-based code where students are fitting together these puzzle pieces of code to build a program that may track and follow a line. It may respond to sound with its own sound, flash lights, complete tasks like navigating a maze that students have coded these robots to do. So they're getting a little bit more of the computer science skills because they're building a program on a software and then making that connection to a hardware, the robot that they have built themselves. And just pulling some of those programming and software standards out once again. Students are getting to explain when writing programs that the initial program environment is necessary to consider. What is the goal that they are reaching towards? Are they navigating a maze? Are they looking to design a dance for their robot? They're creating conditionals using if-then thinking. If my robot encounters a wall, what is the response? Should it stop? Should it turn? Should it say help? And creating a list of steps, an algorithm to solve real world problems. We want to start pushing our students to think about the real world application of these skills and how we see the robotics outside of the classroom solving problems. Our 6th through 8th graders are again getting a little bit more detail, a little bit more complexity in the skills that they are building. So they are getting to create functions. They're getting to use variables in their program. They're developing solutions and debugging. They're testing out their classmates' programs as well, and trying to practice that engineering and design process as it relates to a digital space and a digital artifact in the form of this program. At the 9 through 12 level, we really want to be pushing towards the CTE aspect of STEM. How are we preparing students for careers in these categories? So our third through fifth graders, our sixth through eighth graders have gotten to explore different ideas, different career paths, and our 9th through 12th graders may be prepared to start building very specific skills in those areas that can be useful immediately upon graduation. So our 9 through 12 automation for manufacturing course is going to really take those skills that they have been exploring and bring them to a specific industry skill set and space. So this course is going to simulate the kind of manufacturing and automation that we see in manufacturing in factories and provide students opportunities to simulate that on a smaller scale. So for example, using a simple single board computer like a microbit and a variety of extension pieces, conveyor belts, sensors and sorting wands. They can, for example, simulate a process where a conveyor belt that is delivering M&Ms towards this microbit is then sorting them by color and getting students a little bit of experience in text-based programming as opposed to block-based programming, something that is a little bit more immediately useful at industry level like Python. So again, pulling some of those programming standards out, they'll be writing code segments, identifying errors, debugging, using logic operators and different structures within a program, and then keeping that process of the engineering and design process, iterative solutions at the heart of their work, constantly running, testing, and debugging their programs for different real world solutions. Now, that's just one example of what protected STEM time can look like for a district that says on Tuesday and Thursday afternoons, we have this protected block of 30 to 60 minutes to practice our STEM implementation, or whether it's part of the school day in an after-school program, which is certainly ideal of what STEM can look like. We want to be reaching towards that as our gold standard for STEM, but we know that's not immediately realistic for some schools and districts. So many times we look at the alternative of integrating STEM into core subjects. Some of those examples that we went over before. How can we find a way to bring the technology, the skills, the engineering design process into core subjects that we already know students are getting a lot of practice in, and that has protected time within the school day. We'll look at just one example, and we're going to focus on life science and how we can bring STEM into life science. But certainly ELA, math, social studies, all of these have opportunities for bringing STEM technology or skills in. And this is just one example of what this can look like. So pulling just a few different life science standards out. These are across K through 12, some of the plant life science standards that could be impacted by introducing a STEM topic through hydroponics. So our first graders identifying the major parts of plants, third graders describing the structures and their roles in different aspects of life for the plant. Our fourth graders understanding reproduction, like pollination, seed dispersal. Seventh grade, we're getting to understand a little bit of a larger picture about the role of plants within the local ecosystem, how they are affected by and affecting the availability of food, shelter, water. And then our high school students relating structure to function from a cellular level up. So all of these different standards could be impacted by the introduction of just one STEM technology, which is hydroponics. And again, a major role of STEM and of NextWave STEM in particular is making sure that these are sustainable solutions that are not just useful for one unit, for one grade level, for one concept, but are replicable across classrooms, across schools, across ideas and subjects. So this hydroponic system is one technology that could impact an entire school building, an entire district when scaled. If you haven't worked with hydroponics before, it's a very simple shelving system wherein we are growing plants without soil. A structure in the form of a sponge is provided for roots to take hold, but all nutrients are delivered to the plant through a nutrient solution that is added to the water basin. There are growing lights above, so we're able to control for really successful growth, especially of leafy greens in the classroom. This simple shelving unit is about 1 foot by 2 feet. And so it's a relatively little impact on the space in the classroom, but a huge impact on learning for a variety of grade levels. So for our K through 2 students, this is something that they're going to be covering in their core science classes, the parts of a plant, what do plants need, how do plants get what they need from soil or the nutrients that we provide, the sun, how do they disperse their seeds and reproduce. All of these concepts can be enhanced by bringing in something like the hydroponic technology. So we're getting to control a little bit more for successful growth, maybe alongside the classic seed with a wet paper towel in the window of the classroom. That's something I did, and it has a place for a great way to show students some of the variability with growth and with science in general, as opposed to a hydroponic system that is more controlled. And we're also thinking about bringing in literature to support that learning about roots, about the plants that we eat, and that connection between the science we're learning about in school and the food on our plate. Our middle grade, third through fifth students are getting to build some of those scientific process skills of designing experiments, investigating and implementing those variable changes throughout an experiment, collecting, interpreting, and representing data as they track the growth of their plant. All of those skills are greater than just getting to see this great technology that has been developed as a result of the engineering design process. They're getting that technology component, but they're also getting a lot of additional scientific practice that they may not get with just that seed in a wet paper towel in a bag on the window. Our middle school students, we want to again be pushing towards those real world solutions. How do technologies like this impact the world around us, the human world of work and society and culture, some of those impact standards that we saw early on? They're thinking more about hydroponics and their potential use as a response to food deserts and produce scarcity, or thinking about a big project at the end of this particular unit is building a hydroponic unit that will sustain 6 astronauts on a space exploration program, thinking about how these technologies can impact the world and how they can solve real problems beyond just giving us a great place in the classroom to practice some of those skills. And our high schoolers, our 9th through 12th graders, are broadening that scope a little bit more, where they are thinking about the place of these technologies within a larger industry. So how does hydroponics fit into the world of agribusiness and agricultural science? This is just one part of the many different technologies and developments across this industry. So students are thinking about hydroponics, but also irrigation, land management, pest management. They are growing a wheatgrass. They're then juicing that wheatgrass into a health drink, and then they're designing a business plan to bring that health drink to market. So bringing in some of those cross-curricular and especially career connections for our high schoolers especially to help build out a context and have some of that more higher order evaluative thinking around these technologies. Now, again, that's just one example of how one technology can enhance one set of science standards within Florida schools. But of course, we also see schools who are introducing some of those computer science skills to have students building chatbots that help tell a story, get some of those ELA standards, using drones and robotics to get some of those math standards as well, bringing them into the math classroom. So there's a variety of different ways that you can take that integrated STEM approach if you're not able to provide that standalone STEM time. But as an educator myself, I know that it all comes down to the quality of materials and instruction that you're able to provide. And I heard that from you all in our chat, as well as we've heard from schools all over, that the concern around high quality resources and the instructional quality and training of our teachers to provide this kind of instruction is absolutely paramount. So I do want to provide some time to go over just what it is that NextWave STEM provides and what we're talking about when we think about these STEM units that I've described. Our content is standards aligned, so Florida science and technology standards, as well as ELA and math. We know that not all schools have that standalone protected STEM time, so wherever possible, we're including the ELA and math that is also going to be underscored by this content. ISTE and the Computer Science Teachers Association standards, as well as those 21st century skills. Students are collaborating all throughout our content. They are practicing creativity and critical thinking, as well as communicating what they have learned or built or explored throughout these lessons. So a STEM course with NextWave STEM, our core unit is 15 lessons. Many of our courses have gotten supplementary materials to keep them updated, especially as these emerging technologies have developed and are up to 21 lessons. We include a course guide, a teacher's guide, or a lesson plan for every single one of our lessons. They are highly, highly supportive, just short of scripted. So if your teachers are really comfortable with this topic, they can follow them as a guideline. But if it is a teacher who is maybe teaching STEM for the first time or is stepping into a particular subject they are less familiar with, they can follow them to the letter and feel comfortable leading their students. We also do provide teacher professional development resources on our library that are self-paced, frequently available throughout the entire license of the STEM course. So teachers can brush up on that content as well as the learning activities of the course. Our courses are written with a beginner teacher in mind. It's our job to stay on top of emerging technologies and to distill that information to our educators. And it's your job to provide the high quality education that only you can. So we have teacher success at the forefront of our development of our courses because we know these especially highly complex specific topics can be daunting. But our materials are designed to bring even beginner teachers into the fold on these emerging technologies. We also provide presentations that your students are seeing for all of our lessons, worksheets and answer keys, summative assessments that can be given as a pre and post test, and scope and sequence documents that delineate exactly what standards match each of the objectives throughout every lesson in the course. All of these materials are available in both English and Spanish and are all hosted on our online portal and that we use as a library that hosts also our professional development resources. I want to give you one more look at our offerings as a whole. It can be daunting to see all of these, but focus in on those topics across the top, our pathways, and then our grade bands along the left column. Every one of these boxes is a 15 lesson course. So any combination of them can be put together to provide a semester long, year long, summer camp, whatever curriculum program you're trying to put together for your school or district. The other thing that we hear a lot is trying to secure funding for these sort of programs. NextWave STEM has a lot of experience and resources dedicated to grant funding. We will help you with building a a successful application for grants and helping connect you to some of those resources if that is a concern as well. And also, if you're looking at a targeted approach to your programming, maybe you've launched a new makerspace in your building and you're not sure where to begin on the content, or how your library and media specialist is going to take on computer science as a new program for the semester, or you're looking at a CTE or arts connection. We have these targeted categories identified that we can help build out a custom bundle that will address the specific needs of your school or your district. We are more than happy to work directly with you. I know I love nothing more than really getting in the weeds with teachers and designing programs that most effectively meet the needs of their students, or with administrators thinking a little bit more about school and district goals. So if you would like to see our curriculum samples, please follow this link. You can download a sample for each of our topics. Take a look at our high quality lesson plans that are written with the 5E lesson format. So they are really written to promote student inquiry and the construction of their own learning, a lot of exploration, and they are highly, highly supportive for both the teacher and the student. So I would highly recommend checking them out because I'm very proud of the quality of these lessons as an educator myself. On our website, you'll also see the opportunity to book some time with our team if you would like to learn a little bit more about our programs in specifics. We would be more than happy to meet with you. Tarita is dropping her link into the chat as well. Both of us would be happy to talk through what would be the best fit for your program. Also, we'll stick around for just a couple more minutes. If anyone has any questions that they'd like to drop in the chat or come off of mute to ask, we'll stick around for a couple more minutes here. But hopefully at the end of our time today, if you were around the ones and twos and a little bit quieter in the chat, you're feeling more comfortable moving towards 3 and 4 with us. If you were at 3 or 4, I hope you've gotten a little bit better of a perspective on what NextWave STEM offerings are as they relate to your current STEM programming and your STEM goals. Please, please, please reach out if you have any questions. We would love to speak more with you. Thank you all for being here today. And we will stick around for a couple minutes. If you have any questions, please drop them in the chat while we're here. We're more than happy to answer. All right, this recording will be emailed to you on Monday. And we wish you all a very nice weekend and a happy holiday season.
Thank you, everyone.